Okay, so we are done with Unit 5. We're going to be starting Unit 8 today, and Unit 8 is all about kind of beefing up our inventor skills before we do a reverse engineering project. So there's two big projects within Unit 8, and they're all geared around how to improve the skills that I'm developing in Inventor. So we're going to start with model a Trammel toy, and the only thing you really need for this activity is this PDF. The PDF has the dimension drawings for all the parts that we will build within this activity. And if you look at the PDF itself, it gives you the full assembled drawing. You have the exploded view identifying the different parts. Your parts list also identifies the material, so we'll be assigning material to each of these parts. And then we have dimension drawings for each of the different pieces that have to be built. Some of them are very simple, like the arm pin and the base pin. Some are going to be a little more complicated. I'm going to demo some of these in this activity. The goal when we're done is to get something that looks like this. And the nice thing with this is we can start talking about things like animation, right? So I can build a piece that can then be animated, adding all the shadows. You could make movies out of this. But this is the final project. This is what the final assembly is going to look like, and that's what we're going to start working on today. Before we do that, let's review the process for setting up a project, because we probably haven't done that since the button maker activity. And in order to get to projects, you need to make sure that you have all files closed. Can't have any assembly or part files open to create a new project. So I'm going to click New, and again, this is just a review. I know we've done this before, but to set up a new project, I click New. It's going to be a single user project. I'm going to call this one Trammel Toy. I need to define the workspace, meaning where this project's going to go, and I'm going to do the desktop. I'm going to make a new folder on this specifically for the Trammel Toy, so I'll call it Trammel Toy. Okay. And I want to check, okay, where's the project folder going to be? It's on the users, my user ID, the desktop, and in the folder called Trammel Toy. So that's good. I hit finish. Now everything that I save, anytime I hit open, it's automatically going to locate that folder that I created. So I'd highly recommend doing that first. All right, so let's talk about some of the things that have to be built in this activity. I want to start with these head cap screws, and they're all similar. The size is a little bit different, but I can make one and make modifications to the one so that it looks like the other one. So in each of these cases, I don't necessarily have to do it from scratch. So I'm going to build the knob socket head cap screw first using the dimensions given on this sheet. A couple things too to keep in mind. Anytime in any of the drawings that we work with, when you see a cross-section or a part of the shape that's been cut out, usually it's a hint or recommendation that you build this piece using the revolve function. So although I could make this with extrusions, it would be easier and quicker to do it using the revolve, and I'm going to show you how to do that in just a second. When you do a revolve, you want to draw basically the profile of the shape, but half of the profile. Right? So if I'm looking at this object here, this is the profile, and I'm interested in just drawing half of that. And that center point will be the axis that I'll revolve the object around to make the solid. So I'll start with the first one. Create a new standard part. 2D sketch on the XY plane. And I'm going to start from the origin and draw out the overall length of this screw, and it's 0.841, and this is going to serve as the center axis for the drawing. The overall width of the top part of this screw has a diameter of 0.324, but I want to divide that number in half because I'm interested in half of that profile. Go down 0.216. The last dimension I'm going to set is the smaller dimension on the bottom. And again, that number is going to get cut in half. So if it says the dimension is 0.216, I divide that number in half because I'm only interested in half of the profile. Okay. So that's the sketch. It's fully constrained. I can tell by the color. I'm going to finish the sketch. And I'm going to use the revolve command to make this object. So the axis that I want to revolve is this point here. I hit the check mark, and that's basically done. A couple other things that I need to do from the top. If I go back to the directions here, the top has this hexagon that's extruded into the object. I know that the size is 0.1565 across flats, and so I need to draw that onto my object as well. So I'll start a new sketch on this top surface. I have to drop down from rectangle to polygon, 6 sides from this center point, and I'm not going to be concerned about the dimension now, I'm just going to place the drawing. Then go back and add the dimension. So but across the flats, I know that the size is 0.15625. Finish the sketch. This can be extruded in. I want to cut into the object, and the distance or the depth for that's going to be 0.1. Hit OK. Final step then is to add the threading on the outside of the object. Threading. Hard to see probably on the screen here, but when you look at yours, it'll give you the thread information. It says 12-24 UNC. That's a specific thread size, and I'll show you how to find that in here. So I'm going to click on threading. Here we go. Then I'm going to go to specifications, and this is where I can set the size of the threading. So when you see the 12-24, that's telling you that it's a size 12. So there's certain numbers, like a size 0 through 12. Or if it said corner 20 UNC, then it'd be the size that it's telling you. In this case, we're using the size 12, and I'll hit apply, and it adds that image onto the object. So I would want to save this. This is done. I would save this as knob, socket, head cap, screw, and then I would move on to the next part. So when I look at, let's say, the next part, like this one down here, it's very similar. Very similar process. Some of the dimensions are a little bit different. So rather than starting from scratch, it's probably easier just to manipulate the one that I already made and then save as and call it something else, right? So I can manipulate the knob socket to make it the arm socket by changing some of the dimensions. We're going to talk about that right now. So I've saved this. This is in the folder that I created as a project. Now I'm going to go back in and make changes to the sketch I used for the revolve, right? So I know that in this case, the height is going to be a little bit larger. But the other dimensions are the same, haven't changed. So it's just a little bit longer than the original piece. So I finished the sketch. I need to check, okay, is the threading the same on this? It is, same size. Is the size of the hexagon on the top the same? It is, so I'm basically done. So rather than starting from scratch and building the part again, I made one change to one dimension and I have the second piece that's already built. That's probably the quickest way. Here's the trick though. When you save this, make sure you save as. I don't want to save over the original part. I want to save in addition to the original part, and you'll give this one a new name. Okay. So I would do that probably for all 3 of these. There's no need to rebuild these from scratch once you have the original one. I think this is pretty straightforward. I think you guys can handle that, so I'm not going to talk about that. Same with these, pretty straightforward. Notes like this are telling you that you're going to be using the chamfer, so you can use the chamfer tool to cut these edges off. It gives you the size of the whole location of that. And the only difference between these two is on this second block, the hole is threading. So it has threading in that hole. Again, if I built the slide block, there's no need to start from scratch again. Just add the threading to that hole and save as the other part. All right, I'll do one more example with the revolve. Again, it's showing me the cross-sectional shape of the object. Okay, I'm seeing the inside. I'm thinking if I draw that profile, that I can revolve this to be the quickest way. Here's the thing. In this case, I want to do the revolve, but I'm going to disregard the hole. In this case, it's a counter bore in the center. I'm going to act as if it's one complete solid object. And I'll go back and add the hole after the fact, after I do the revolve, because it would be less math than trying to figure out what all these sizes are. Okay. So I'll start a new sketch. Sorry, I'm going to start a new part, and then a new sketch. I know that the overall height for this knob is 0.75. The larger diameter on the top of the knob is 1, so I want to do half that size. That height is 0.4375. And then the smaller the diameter underneath is 0.65, and again, I want to divide that in half because I'm going to be doing a revolve. Okay, so I'm disregarding the fact that there's more to this profile for the counter bore that's being cut in. I want to add that after the fact to be a lot easier. Okay. So I have this. I'm going to finish my sketch. I'm going to revolve around this center axis and finish the sketch. Now I'm going to go back and add the counter bore on top. So to do that, I click on hole. Notice that I didn't create a sketch to start the hole. I didn't add a point. I can actually use the features within placing the hole to do that. So instead of a linear placement for this hole, I want concentric because I want the hole in the center of my face. And when I do that, I can click the face and an edge as a reference, and it automatically places it in the center. So I didn't need to create a sketch first or place a point in that middle. I could use concentric reference to place this hole on there. Okay, this is a counter bore. The largest diameter, the outside diameter for this is 0.375, which is good. The depth of that counter bore is 0.375, and then the smaller diameter is 0.25, which goes the rest of the way through. So I have all the settings I need. Check mark, and now I have the hole inside that object. So in this case, it'd probably be quicker to do the revolve of just the profile, go back and add the hole. I didn't remember to look up the material, add the material to the previous examples, but we do want to go based on our parts list. So this is a crank knob. It's telling us that it's ABS plastic. So when I go back into material here, I'm looking for ABS plastic, and it assigns that material to the object. Okay. I'm going to save this, move on to the next part. So we're working through here. Did this. I think this is pretty straightforward. Again, this is going to be a counter bore, so make sure you're using those settings when you place the hole. I'm going to go over one more, the base plate, which looks daunting, lots of holes, but if we use some mirror commands, we could actually do this fairly easily. So this will be the last one that I go over before I turn you guys loose. So one more new part, standard part. I'm going to start by creating a sketch on the XY plane and using the rectangle command to make the overall size of that base piece, which is 4¼ by 0.565 tall. So 4.25 for the width, 0.565 as the height. And I want to extrude this object 4.25 inches. Okay, so that gives me the overall base plate. When I look at the directions, there's two types of holes on here. There's a standard hole that they appear to be a little bit larger, have a diameter of 0.25, and they go all the way through. There's also some threaded holes. So I have a 1/4 UNC, and it gives me the depth as well. So I'm just going to focus on this corner right here. I'm going to focus on those 4 holes, and from those 4, I can mirror the rest of the holes. Again, I don't need to place a sketch on here or points. I can just go right into the hole function and reference the edges as I'm placing my holes on this drawing. So I'm going to use linear as the type of hole. And I'm going to click on the face. The dimension for the diameter is correct. Now I can reference the edges. So reference 1. From this edge, I want it to be 0.375 away. And from this edge, 0.375 away. If I'm happy with that, I'm going to hit apply rather than OK because I want to keep adding holes. OK will close out the hole command. Apply will allow me to keep working. I know there's another hole just like that one on this opposite corner, and I can reference the edges. 1.5 inches from this edge, 1.5 from the back edge, and I hit apply. Okay, so I've done the 2 of the 0.25 diameter. Now I'm going to worry about the ones that have the threading on it. So I'm going to hit the tapped hole here. And this is the setting I want, 25, 1/4 UNC. Same process. Select the face, reference the edge, 0.375 from this edge, 1.5 from this edge, apply. One more hole, 375, 1.5, and apply. Now, this process could be repeated for all of the holes on here, but that's a little bit tedious. I think once you have these 4, we mirror the rest. And to do that, I'm going to add some planes in the middle of my object that we will use to do the mirror on. So I'm going to click on plane here, and I'm selecting this front surface. If I hold down F4, that's my hotkey to free orbit, and this back surface. And when I select those 2 surfaces, it puts a plane between the 2 surfaces I selected. I'm going to do the same thing between this surface. Again, F4 is the hotkey for free orbit, and this surface. And I can use those planes to mirror the holes to the other sides. So now that I have that, I'm clicking on mirror. I'm selecting my features. I like to do it just in the browser to make sure that I selected them, and they turn blue, so I know that those ones have been selected. Then I'll select my mirror plane. In this case, it'll be here. Hit OK. So I've copied all that information on the other side. I'll do another mirror command. Select all the original holes, plus I have to select the mirror that I already did. Select the mirror plane, this new plane, apply. So it's added all the holes. It's probably the quicker way to do that. When you're done, you can actually hide these planes. You can't delete them because the mirrors are dependent on them, but you can turn the visibility off so that I no longer see that. Make sure that you assign the material on it based on the parts list in the activity sheet. And our goal then is to have built all of the 11 parts in this object so that we can talk about the assembly next. Make sure you set up your project first, and I'll give you the next couple of days to work on the modeling of these parts.